Okay, we will change our power level to 75 by lowering the regulating rod. Okay, now we are critical at 75 kilowatts. So here we will fill in again the power level checklist form. So here the power level is at 75 kilowatts, and then the position of the control rods are at 100, 70, and 41%. And to lower the power from 100 to 75, we have to lower the control rods by only 5%. So we can see that the control rods position is not linear to the power level. This part will be explained when we do the control rod calibration this afternoon. So you can see how is the graph of the control rod reactivity. Okay, now we continue. So here at 75 kilowatts, the primary cooling system, the flow is still constant because we didn't change the flow rate. And then the temperature for the primary inlet is at 27 degrees Celsius. And then the outlet is at 26.4 degrees Celsius. And then for the secondary flow, we didn't change also. So the inlet is at 25.4 and the outlet is 25.8. But the interesting part here is because of the lowering of the power level, the IFE temperature is also goes down. So initially it was at 130, 136 I believe, and now it is at 107 degrees. So by lowering the power output by 25%, the IFE temperature goes down by almost 20 degrees, 20 to 30 degrees. Okay, from here we can also look at the radiation levels. So, if previously the radiation levels at the deck at 100 kilowatts was at around 3.2, 3.3 milliroentgen per hour, but now it is only at around 2 milliroentgen per hour. So we can see that the radiation exposure at the deck of the reactor is proportional to the power output of the reactor. And also we can see at the background, at the demineralization system, that the radiation exposure at the demineralization system has started to increase, where previously it was at around 0.9, but now it's already at 1.2, yeah, at around that level. So it is starting to slowly increase. Also, another thing that you can see, by lowering the power level, we can see that the Cherenkov radiation is not as bright as before. So previously it was at 100 kilowatts, and now it is only at 75 kilowatts, and the luminescence of the Cherenkov radiation is quite low. Okay, now we will have to increase the power level back to 100 kilowatts. But now we will see from the Cherenkov radiation and see how much it changes in luminescence. Yeah. Okay, now we are at 100 kilowatts. Well, the changes is not that drastic because it is only from 75 to 100 kilowatts, but maybe if it was from say 20 to 100, the changes will be a lot more prominent. Our operators will change the power level to 60 kilowatts. Okay, now we are at 60 kilowatts. So as you know, to lower the power, it is a lot quicker than to increase the power, because to lower the power, we don't have to take care about the period, but when we increase the power level, we have to take care about the period to prevent the scram. So now we are at 60 kilowatts. Here we will try and see the levels of productivity and also the channel composition. So for the radioactivity, for the system at the deck, it will be a lot lower compared to 100 and compared to 75. So if previously the radiation exposure level at the 100 kilowatts was at around 3, and then when we were at 75 kilowatts, it was at around 1.8. Now at 60 kilowatts, we are at around 1.4 millironson. And when we look at the system, at the demineralizer system, we can see that the levels is also starting to go quite high, because it was previously at 1.2. Now it may reach around 2 microsievert per hour. So yes, the strong point that I would like to give to you here is that the radiation exposure level at the deck is proportional to the amount of power level generated by the reactor core, and the radiation exposure at the demineralization system is proportional to the amount of time of the reactor operation. So here we will fill in the form again. We will lower the power to 55, and then after this we will start to do the shutdown process. Okay, now we are at 35%. So if previously we were at 100% power, and the power was at 170 and then 47, and then we went to 75% power, we changed a little bit the position of the control rods and mainly the regulating rod, and then we increased the power level to 100% by raising the shim rod, and now we are lowering the power using the regulating rod and the shim rod. So previously it was at 177 and 32. Now the control rods are at 170 and 32. With the fuel temperature going even down. So if it was at around 93 degrees at 60 kilowatts, now it is only around 75 degrees Celsius. So it is quite warm only. So not as hot as before. And now, maybe from your speakers you cannot hear, there is no beep from the gamma area monitor, because the gamma area monitor is typically set at around 50 kilowatts. So when the power level is at 50 kilowatts, there is enough radioactivity so that it triggers the gamma area monitor to give out a beep alarm. So now I would like to show you the radiation exposure at 75 watts. So the radiation exposure at 35 watts is comparatively very low compared to the power level of 100%. So if initially the radiation exposure at the deck was at 3. Now the radiation exposure is only 0.7. So it is almost 1/3 the exposure. So it is considerably a lot safer to work right now at the deck compared to when it was at 100%. But typically, well, when we are working on the reactor deck at 100%, we can do it, but we have to take care to do it quickly so we don't have enough radiation exposure that we receive. And also we can work a lot further from the deck, so we are working on the perimeter of the reactor.